All right, so let's take a look at problem 25. This is Math Counts 2015 sprint round. We're going to start at 25 and go as far as we can. So, on a standard die with 6 faces, each face a different number 1 through 6. Jake, thank you, Jake. Instead of writing 1 through 6, you decide to write A and B's in equations. That's really helpful, buddy. So we need to figure out what A times B is. And already I have circled, boxed, 2 equations, one with an A and one with a B. And when we have 3A minus 10, we know that that's really going to limit the values for A, because if, for instance, A was 2, we get 6. 3 times 2 is 6. Minus 10, that's negative, that doesn't work. And if we do, I don't know, how about 7? 21 minus 10, well, that's way over. Or even 6, right? 6 minus, so it's 18 minus 10 is 8. So that's not going to work. So really, A has to be either 4 or 5. So let's plug in 5. So we get 15 minus 10 is 5. 2 times 5 is 10, minus 5 is 5. We have 2 5s, that doesn't work. So right away, I know that A has to be equal to 4. And I can just go through and double check this. 3 times 4 is 12, 12 minus 10 is 2. 2 times 4 is 8, 8 minus 5 is 3, I hope. And 4 plus 1 is 5. I hope I've done that right. I'd be super embarrassed if I did not. Now let's take a look at B. So we have 3B plus 10, and we also have B plus 8. And that tells me right away that B has to be negative. B has to be negative. But over here, if B is negative, we can't go above negative 2, because negative 3 times 2 is negative 6. Negative 6 plus 5 is a negative number. So I know that B has to be either 1 or 2. Let's start with, negative 1 or negative 2. So let's start with negative 2. So negative 2 plus 8 is going to be 6. That's okay, I don't have a 6 yet. Negative 2 times negative 2 is negative 4. Negative 4 plus 5 is is 1. And finally, negative 2 times 3 is going to be negative 6. Negative 6 plus 10 is 4, so it works. So I know B is equal to negative 2. So then, negative 2 times 4 is 8. All right, next problem. For a particular sequence, A, the first term is 3, the second term is 5. So let's start writing this out. So we have 3, 5. I like making a little table. And let's just see what else the thing says. So then it goes on to say, there has to be a pattern, or else we wouldn't be able to figure out the 215th term. That would be impossible. So the pattern can't be too long. All right, so then we know that n, it has to be greater than 3. Great for this, because you need 3 terms. So this is saying a to the n is going to be equal to a to the one preceding it minus the one that was 2 before it. So that means for the third term, we'll have the second term minus the first term, right? So that's 5 minus 3, which is 2. For the fifth term, I'm going to have 2 minus 5, which is negative 3. Then we're going to have negative 3 minus 2, which is negative 5. We're going to have negative 5 minus negative 3, and that's going to be negative 2. Then we have negative 2 minus negative 5, and that's going to bring me back to 3. Oh. Well, once we get to 3, let's go ahead and double check. So then 3 minus negative 2 is 5. We know now that this is going to repeat. Every 6 numbers, we are going to repeat the process again and again and again. I don't know about you, but the prospect of having to write this out 2015 times makes me want to poke my eyeballs out. Hopefully you won't resort to such extreme measures, but there's got to be a way to figure that out, no problem. And so let's go ahead and, oh, well, you know, this seems like one of those remainder problems, right? So we don't really care how many times 6 repetitions go into 2015. What we really care about is the remainder, right? And so 6 goes into 20 3 times, carry the 2. 6 goes into 21, oh, I don't know, 3 times, carry the 4. 6 goes into 45, 7 times, and that gives us a remainder of, I feel like I have done something wrong. Like my division is not okay. Maybe my shorthand is suffering. Oh, yes. Because 11 minus 18 is not 4. 11 minus 18 is 3. So that would be 5, because 6 times 5 is 30, and I have a remainder of 5. So what does this remainder of 5 tell me? Well, the remainder of 5 tells me that the 5th term in my sequence will also be the same as my 2015th. So that means my 2015th term will be negative 5. All right. Desi flips a fair coin 8 times. What is the probability that you'll get the same number of heads and tails? Express your answer as a common fraction. Well, the first thing I would like to do with a probability problem is to figure out how many different possibilities there are. So, and I know in binomial probability, if I have 8, it's going to be 2, because I have 2 possible outcomes each time, to the 8th, and 2 to the 8th. Oh, jeez. So 2 to the 5th. Really, I should have this memorized, but I don't. Is 32, 2 to the 6th is 64, 2 to the 7th is going to be 128, 2 to the 8th is going to be 256. Okay, so I know my denominator is going to be 256, at least before I reduce. So then I need to figure out how many ways that we can get, what's it called? 2 heads. Or 4 heads and 4 tails. Well, so that means that I have 8 flips, right? I'm looking for any combination that has 4 heads or 4 tails. Oh. Well, so we know this equation. And we also know the shorthand for this is simply going to be 8 choose 4. And so we have 8, that's 9. 8 times 7 times 6 times 5 over 4 times 3 times 2 times 1. Well, that's really useful, that 1, right? So 4 times 2 is 8. 3 times, I'm just reducing. So we have 1, I like that 1 there. And so we have 10 times 7, so that's 70 different ways we can get 4 heads and 4 tails. Well, let's see. I know they're both even, so let's divide it, reduce everything by 2. So we have 35 over, that's 1, that's going to be 2, carry the 1, and that's 8. Well, I know 5 doesn't go into it, and I don't think 7 goes into it either. It does not. So I think my final answer is 35 over 128. Yay! Oops. Come on. All right. So how many ordered pairs of integers x, y satisfy the equation x plus the absolute value of y is equal to y plus the absolute value of x? All right, and x and y have to be between or equal to -10 and 10. So right away, I know that if there are 4 different possibilities. I could have 2 positives. I could have a positive and a negative and a positive, or 2 negatives. So let's take a look at each situation. If x and y are both positive, I could have a 0. I could have a 0, and I could go all the way to 10. So how many different numbers for x are there? So that's equal to 11 possibilities. For y, I have the same thing, which is 11 possibilities. So that means I have 11 possible x's, 11 possible y's, so that is 121 possible choices. Positive x and a negative y. Well, if I have a positive x and a negative y, but this y is going to remain negative, that's not going to work so good. It's not going to work at all, actually, if y is negative, because the absolute value of x can never make it. So we know that we have none of these. Likewise, same thing can be said for this equation. If x is negative, the absolute value of x can never make it. So we don't have any of those situations. What happens if both of them are negative? Are we able to do that? Well, well, we're thinking, what if x and y were opposites? Would that work? Well, not if they're opposites, but if they're, in other words, what I'm thinking is, can we make this expression 0 and this expression 0? Well, if this was, say, -1, and that one +1, the only way to get +1 would be the absolute value of -1. It's equal to -1 and the absolute value of -1. Okay, so that's work. So if both numbers are exactly the same, then it would work out, because they'd both end up 0. Okay, so that means they could be they could be 0, -1, -2, -3, -4, all the way to -10. So that gives me 11 additional options. So, Two, 3, 4, 5, 6, 7, 8, 9, 10. Oh, right. Okay, so I'm trying to think about what happens with the 0, because 0 is neither negative nor positive. So I've already counted the zeros over here. I'm sorry that I'm working through it in my head, but on the video. It doesn't make for great listening, I understand. So that means I've already counted the 0 and 0 combination. So that means I have only 10. Yeah, that makes sense. Okay, so then I have 121. This one is including the 0, 0 possibility. Plus I have the 10 more if they're both negative, so that's 131. Is that right? Okay, yes, it is. Excellent. All right. For number 29, when 1 over 98 is expressed as a decimal, is the 10th digit to the right of the 10th decimal? I don't know. Who cares? Well, we do, apparently. I would just crank this one out. 3, 4, 5, 6, 7, 8, 9, 10. I don't know what else to do. this seems like a waste of time. So anyways, that's 98. So you drop the 2, obviously, so then there would be 2. So that would be 196. It's going to be 4. Drop the 0. Drop another 0. It seems like a royal waste of my time. So then that would be 4, 0. And right now, I'm starting to notice that we're getting a pattern here. That's going to be 0. Sorry, that's going to be 6. That's going to be 0. That's going to be 8. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Huh. And we want the 10th digit to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, that's the 10th digit. All right. And finally, actually that didn't turn out to be so bad once you notice the pattern. Okay, so this one I'm going to have troubles with, right? So what is the greatest all possible of m, where m is the exterior angle, m is the exterior, side of the polygon. So here's what I'd be tempted to do. I'd be really tempted to make a table out of this one. So if I have a triangle, so that would give me the degrees, right? So be 60, so 180 minus 60 is 120. If we have 4-sided figure, we have 90. 5-sided figure, that's going to be 540 divided by 5, which is 108 per side length, right? And so then 180 minus 108 is going to be 72 for a 6-sided figure, so add 180 to that, so we get 2, so 720 divided by 6, so 6 goes into 72, doesn't go, it goes 1, carry the 1, 2, 0, so then that would be 60, that makes sense. For 7, 180 plus 720 is going to be 900 divided by, now that's just not an integer, so we know that's not okay. So then we know that for 8, so we have 1, so that's 10,080 divided by 8, so that is going to be 2, carry the 2, it's going to be 3, carry the 4, 5. I don't think I did it. I'm starting to get a little slap happy, so I'm just going to cheat here. So, thank you, because that's a 1 idiot. The idiot's myself, right? So that's negative plus 180. I get 45. All right. Let's go a little bit further. So I have 180 plus, okay, divided by 9. So that's going to be 40. I'm going to go to 10. So that's going to be 8 times 180. So So 1 so divided by 10. So 180 minus 144. I get 36. All right, and so I can continue in that manner. And so I'm being asked, I'm going to stop there for now. One example, because the measures of each, what is the greatest of all possible values of m? And so if I were to continue this, I would never get the answer. Okay, I'm sorry that I wasted your time. So since I know this isn't going to work, there's got to be another way. So, well, I can start looking through the equations. I mean, that sounds pretty gnarly, but let's go for it. So we know that well, we know that each exterior angle of a regular m-sided polygon, of an n-sided polygon has a degree measure of 360 divided by n. And so again, that is the exterior angle of an n-sided polygon. Obviously, you're supposed to know that, right? And then the exterior angle for a m-sided polygon is going to be 360 over m. And this must be background knowledge. And so we want to figure out the n, because the n one will have a larger exterior angle because it has less sides. So we know that 360 divided by n minus 45 is going to have to equal 360 divided by m. And now we just have a algebra problem, and we're trying to figure out the greatest possible value of m. So we need to get this m by itself. All right, here we go. All right, so the first thing we want to do is get rid of the denominators. So we're going to end up, I'm going to multiply everything by mn. So that means we're going to get 360 m, the n's will cancel out here, minus 45 mn, because there's no denominator to cancel anything out. And that's going to be equal to 360 n. My m's will cancel out here. So then, 45 goes into all of them. So I'm going to divide everything by 45. And so when I get that, I'm going to get 8m minus mn, excuse me, is equal to 360, so no, 8n. I think I'm over my 15 minutes. All right. And so, again, we're trying to get the m's together. So right now I know I can factor out an m here. So I get m, factoring out the greatest common monomial. So we get 8 minus n is equal to 8n, which means m is equal to 8n over 8 minus n. Great. Now let's make a table. All right, so here we go. So my n value and my m value. When n is 1, we'll get 8 over 7. 8 over 7 is not an integer, no good. 2, get 16 over 6. 16 over 6 is not an integer, doesn't work. 3, so we get 18 over 5, not an integer. 4, so we get 32 over 4, that is 8, and oh, that works out, it tells us right there. So we know we're on the right track, finally. 5, we get 40 divided by 3, not an integer. 6, we get 48 minus 2. 48 minus 2, sorry, 48 divided by 6. Well, that is an integer, that's 24. So it might be 24. Let's try 7, and we know it can't be more than 8, right? So 7, get 56, 56, and then when n is 8, we get 0, which is undefined. You can't do it. So my m value is 56. The key to this one is knowing this conjecture right here. If you know that conjecture, you can do this problem really quick. If you don't, you are going to struggle, like I just did.